Hello everyone! Chapter 6, Video 5, Quadratic Trig Equations. This is Mrs. Oshier.
And Miss LaHart.
And here we go. So, here we go.
Yep.
Example 1. Solve for cosine squared theta minus 3. So what you need to realize is that this cosine squared theta business is just like an x. You can just treat cosine theta like an x. So if it makes you feel better, rewrite it as 4x squared minus 3. If it doesn't make you feel better, leave it as 4 cosine squared theta minus 3 and just theta. There we go.
Yeah, true statement. So all we did is cosine squared, we just moved it to x, and then we solved that equation by adding 3, dividing by 4, taking the square root. So now I have that x is equivalent to plus and minus square root of 3/4.
So now we have to remember that we were actually dealing with trig, so we have to pop that cosine theta back in.
Mm-hmm.
So where is cosine of theta, positive or negative, the square root of 3/4?
Well,
we can simplify that.
True statement. Okay, so as you did in the linear equations, you always figure out the angle measurement for the positive value.
Mm-hmm.
So you're going to do second function cosine, well, not second function anymore. Inspire, you just go to cosine to the -1,
Yep.
the inverse, and plug in 3/4, and out will pop 30 degrees.
And just saying, you should realize that this is root 3 over 2, and you should know that 30 degrees cosine is root 3 over 2, because you should know your unit circle.
Right, but you don't have to rationalize to put it in your calculator,
No, you
which
don't.
makes it nice. Oh gosh.
Oh,
So
okay.
then it was 30
there we go.
degrees.
All right, and we're back here. Okay.
So if we go back to the original equation, we're looking for where it's positive and negative. So that means pretty much all 4 quadrants are going to work. So you will reference angle all 30. So there we go. Boom, boom, boom.
Boom, boom, boom. And notice up here, as we just said, it was from 0 to 2 pi.
Mm-hmm. So that means your answers need to be in radian measure. So there you go.
So pretty.
Mm-hmm.
Okay.
Oh, look.
List them
Theta
nice and
equals-
pretty at the end.
Yep.
Okay. So, another example. Solve 2 sine squared x minus 3 sine x plus 1 equals 0. Again, sine x, sine theta, sine blah, 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 blah. It's all just one thing together. So you can change those sine squareds, sines, whatever, all to just x's on their own.
Mm-hmm.
Or not, whatever you want to do.
Right.
Okay.
And then now it's just factoring. Okay. Oh, I actually think I did this all out. Look at that.
Boom, 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 boom. We're not explaining this to you, but it's there if you need it so that you can check your work, etc. But you're factoring.
Mm-hmm. So now that you have your solutions, you set them each equal to 0 and you solve. So now you have 2 spots, x equal positive 1 and positive 1/2.
So now we pop the trig back in.
All right. So first one's easy.
Sine of theta, or sine of x, is 1 at 90 degrees.
True statement. Remember, the sine is the y value. So where's the y value? Positive 1, 90 degrees.
And yes, you can do sine to the -1 on your calculator, but that's boring.
It'll pop out 90.
Bam.
So there's 1. So now we have to go after the 1/2. Okay. So it's 30 degrees. Sine
Boom.
is positive in 2 quadrants.
So you have 2 answers.
2 answers. Well, technically this one has 3 answers.
Right. I just meant with this one.
Oh, okay.
Yep.
Gotcha.
30, 90, 150. All together. Boom, boom, boom.
Mm-hmm.
This is from the ASTC business, just as a reminder.
Okay. And
So
now,
I'm so scared. There's 2 things. What do I do?
well, let's give them each a different variable. So let's let cosine equal x and secant equal y,
Okay.
and then plug them in.
Oh, look at that. Wait, they have an x in common.
Ooh, GCF, GCF.
Algebra is consistent, people. Look at that. Boom.
So yes, that other one is pretty ugly, but you have x times the quantity 2 plus square root of 2y.
And you could have done that up here. You could have realized there was a cosine theta and a cosine theta and GCF that cosine theta out.
Right, just some students like to work with x and y's.
Uh-huh.
So then you set each piece equal to 0.
Boom.
And then you set, well, we're going to solve that one. So we would
Subtract
subtract
2.
2 divided by the square root. And because you don't need to rationalize, you can actually leave your answer like that. But let's go back to 0. Cosine is the x. Where is the x 0? X is 0 at 90 and 270.
Yeah, that's what I have.
Oh,
I just didn't do the other one.
okay. Gotcha. So then we'll go after the other one.
Wait,
The x is 0.
x is 0, sorry.
So that would be,
I was just excited.
yeah, that's
0 and 0. There we go. Now my brain is working. And 0 and 0. Okay. I just saw that 0 and I got really excited because I love the unit circle.
Ding, ding, ding. Did you hear the sound
Ding,
effect?
ding, ding. Wrong answer. It's okay. Happens to everybody. How it goes, people.
All right, let's move on and let's go after the secant of negative 2 over radical 2. So again, remember, you always evaluate the positive. Oh, I used cosine. I
Boom.
did the reciprocal.
You gotta do the reciprocal because I don't want to deal with secant. No,
That's true.
Thank you.
Okay, so you'd plug it in. You know that cosine's negative in those 2 quadrants, so those are the angles you're looking for. So then if you plug in the positive value.
Not the negative is just the position. That's what she just said, just reminding you.
Just put in the positive, make your life easier, and then go after reference angle.
But 45 is not the answer.
True statement.
Because
but that
it is not in that quadrant.
Yes, so it's your reference angle, so 180 minus 45 and 180 plus 45 will get you those two angles.
Boom.
So I think I wrote it one more time nicely. Oh, no, I didn't.
So 90, 270, 135, 225.
And those would all work.
Bam. Okay, here we go. So we have a tangent, a cosecant, a tangent, a cosecant, a cosecant. So again, if it's easier for you to see it, switch it to A's and B's, X's and Y's, smiley faces and sunflowers. It really doesn't matter. It's just a variable.
I think mine.
So now I can see it way easier here. I have the same thing on both sides of the equation. So I can.
Oh, there it is.
Oh, there we go.
I knew it was over there.
So we can just subtract that 3b over and I get a 0 and add the ab over and I get plus ab.
Right.
So
get everything over to one side.
And now having it all over here with those a's, you should be seeing those a's pop out at you for the GCF. And now we have our two factors.
So we stick our trig functions back, so the tangent of theta is 0. So now, remember, tangent's the y over x. So where would it pop out as 0?
So it's a fraction. In order for a fraction to be 0, my numerator has to be 0, which means my y has to be 0. Now let me be very careful this time. And right here. Okay, there we go.
So that's going to be... Oh, I can put it like that.
So fancy.
Wow, look at that. So we got 0 and 180. All right, so now let's go after the other one. So we're going to stick cosecant.
So remember, b is the other one.
Yep.
Okay.
Oh, so we solve for b. So we get negative 1/2. So then we put back the cosecant, but then we don't like dealing with cosecant, but sine's a lot prettier. So again, it's just the reciprocal.
Bam.
So sine is negative in 3 and 4. So then you're going to do second function sine of 1 over radical 2, and you get 45. And then you just do 180 plus 45 and 360 minus 45. And there are your
from
other
the
two.
x-axis.
Okay? And remember, equations you can always check. So you can plug all these into your calculator to see if one side equals the other side to see if you got your answer right.
We can show you a fancy way that's a lot faster to do that as well in class, where you can just type the whole thing in with x and then just substitute these values in. It's fancy. And that'll be a faster way to check, so you don't have to type this thing out every time.
True statement.
But that's how you could check. So that's it.
See you tomorrow.
Have a fantastic day. Goodbye.